So in this tutorial, we're going to quickly go over friction graph. The concept of friction graph, we're going to understand by using this problem. A table made of wood, a box sitting on the table, also made of wood. Okay, wood is moving on wood. Okay, what does that mean? Mu s is 0.4, mu k is 0.3. The last video we explained the friction. This video we're not going to explain about friction. Okay, so we're going to create a table. We're going to write applied force. We're going to write force of friction. We're going to write Fg. We're going to write F normal, and then F net, and then of course acceleration and free body diagram. Okay, so this is the box, 10 kilogram. You apply 0 Newton. If you do apply 0 Newton, what happens? Then force of friction also 0. We're going to use G is negative 9.8 meter per second square. So what is the weight? mg, m is 10, g is negative 9.8. okay, I already have the arrow, so I'm not going to put the negative. I already have the direction. I don't have to put the direction over there. So 98. I do not have the arrow, so I'm going to put the direction. I have the arrow, that's why I did not put the negative. I do not have arrow over here, I'm putting negative. Fn is equal in magnitude but opposite in direction. Why is that? Is because the object is not moving up and down. Why is that? Because there is no net force. Why is that? Because there is no acceleration. So this is positive 98. F net. What is F net? Fa minus Ff, which is 0. If net force is 0, acceleration is 0. How many forces acting on it? Only 2 forces, Fg and Fn. Okay, now the object doesn't move if you apply 0 Newton. So you decided to apply 10 Newton. What happens if you apply 10 Newton? Force of friction becomes equal in magnitude, opposite in direction. And that is force of friction. Okay. Is object moving? You don't know. So you have to find out whether object is moving or not. Fs max, mu s Fn. Mu s is 0.4, Fn is 98, so 39.4. Object is not moving. Why is that? Because 10 is smaller than 39.4. Force has to be more than 39.4 for this box to move. However, 10 is not more than 39.4. So object is not moving. The weight is the same, normal force is the same, net force is the same, 10 minus 10 is 0. If net force is 0, acceleration is 0, 4 forces acting on it. This is applied force, this is force of friction, this is Fg, and this is Fn. Okay, now if you're going to use, let's say 39.1 Newton. This 39.1 is bigger than 39.4. I think this is 39.2. No, 39.1 is smaller than 39.2. So what does that mean? Friction immediately become equal in magnitude, opposite in direction. If this is 39.1, this become negative 39.1. Opposite, equal in magnitude, opposite in direction. The weight is still same. There is nothing going on the y direction. 39.1 minus 39.1 is 0. Acceleration is 0. Force. 4 forces acting on it. This one cancel with this one. This one cancel with this one. Okay, very good. Now we're going to do let's say 39.3. If you do 39.3, what happens? Okay, now 39.3 is bigger than 39.2. So is kinetic friction taking over. So mu k Fn. Mu k is 0.3. and Fn is 98. So 29.4. Okay, so drop is to 29.4. The weight is still same, the normal force is still same, and this is 0 and this is not 0. Net force is not 0 because 39.3 and 29.4 is almost 10. Acceleration is 1. And force body diagram, you have a net force at this direction, so this is big. All the four forces acting on it, the box is accelerating to this direction because there is a net force of 10 Newton and acceleration is acceleration of 1 meter per second square. All right. So 39.4, 39.3. So let's say let's put 60 Newton. Okay. So then what is this one? This one cannot go lower than that, 29.4. Okay. So negative 98. So let's say this one is 30, this one is 60. So net force is, normal force is 98, net force is 30.6. So this is 3. Okay, so you have loss of net force at the x direction. So it's accelerating even faster. Velocity increases tremendously. Okay, now we're going to use this to draw the friction graph. So friction graph, here you go. Okay, so this is your FF, this is your FA. Okay. Okay, so what's going on? This is your FS max, 39.2. This is your FK, 29.4. Okay. All right, Newton. Okay, so now next I'm going to draw 7 or 8 more graphs to help you understand this graph. You pretty much understood something. Now I'm going to quiz you, give you a quiz. So graph number 1, graph number 2, graph number 3, graph number 4, graph number 5, graph number 6. This is your FA, 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 this is your FF, 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 FF. Okay, so now what are you going to do? You're going to draw the graph. You can divide the graph 3 distinct regions. 1 from here to here is 1. This one is 2, and this one is 3. Why is that? Because from here to here is static, and from here to here is kinetic. Why is that? Because from here to this one is FA is equal to FF. This one is FA is greater than FF. This one is FS max. Okay, very nice. So then what is this one? This one object is at rest. This one object is in motion. So what is this one? Acceleration is 0. Acceleration is either greater than 0 or smaller than 0. Acceleration never 0. So what is that? Fs is less than or equal to mu s Fn. Fk is mu k Fn. Graph, let's do one more graph. Ff, Fn, Fa, Newton first law, Newton second law. Okay, so this is your graph 1, this is your graph 2, this is your graph 3, this is your graph 4, 5, 6, and 7. Let me give you a quiz to help you understand. Uh, so let's say rubber on concrete. So you have a car, 1000 kilogram, okay, and uh, applied force is 8819 Newton. This car, same mass, 1000 kilogram, applied force is 8820 Newton. This car is same mass, 1000 kilogram, applied force is 8821 Newton. Scenario A, scenario B, scenario C. Let's draw a friction graph. F applied, F friction. I'm going to draw three regions: region A, region B, region C. Actually, let's call it 1, 2, and 3. Diagonal line 1, the peak 2, and the horizontal line is 3. Mu s is 0.9, and let's find the weight of the car. The car is 1000 kilogram. Let's use acceleration due to gravity negative 9.8, so 9800 Newton, which is the weight of the car. Normal force is equal in magnitude, opposite in direction, 9800 Newton. Of course, we're going to find static friction max, 0.9 times 9800, 8820. 8820 Newton. Now let's check 8819 is less than 8820. Wait a minute, by mistake I put 9820. So this must be at location region A1. So scenario A is belongs to region 1. Scenario B, 8820 is equal to 8820 is location 2. 8821 is greater than 8820 location 3, which is Newton second.